Hi, my name is Daniel Mesko, and this is my presentation on the Java concept wrapper classes. AP Computer Science, period 4 do. Okay, so wrapper classes do two things, basically all related to one main thing. They convert primitive data types to objects of a class, also known as wrapping the variable. Why would you do this? Well, you do this so that you can manipulate those objects through methods. The wrapper class has methods, so if you make it an actual object of a class, you can call upon those methods to do stuff that you wouldn't be able to do with just an integer or a double. So there are four main types of wrapper classes. There's the integer wrapper class, double, boolean, and character. And they all have a capital letter in their declaration.
In their syntax.
Yeah, in their syntax. That's important because that'll make the distinction between a double, that's not capitalized is a primitive data type. Okay, so the conversion is relatively easy. It's just like you would convert an object to a variable to an object of a class. So here are two examples. One is you create the integer I equal to 9, and then integer test, I just named test as an object, equals I. Or you could do it like we declare objects of any other class we create. Integer test equals new integer I. So you're actually creating the object with the formal declaration. The newer one is the one above. You can actually do it like you would do a primitive data type without having to do a new instance of such class. So it's much cleaner. It's the post-Java 5.0, the syntax above, which we are beyond now, obviously. So the syntax above is more efficient and cleaner, but you can do either one. I just put the bottom one so you could see where it comes from. So here's a couple examples. The declaration of the pre-Java 5.0 version is in the comments. You can see for integer, capital I, integer object, capital B for double, capital B for boolean, and capital C for character, and it works just the same way for the variables, whether or not they're a double value, an integer value, or a boolean. It's straightforward. You just convert it to an object. And what I didn't actually mention, what you can also do is, like for example, what they did here for integer IC equals 7. You can either do a variable as your argument. Well, that's not going to work. You can either do a variable or actually just the number if it's a double or an integer, like they have 7 here or 1003.45.
Yeah, you could just use the mouse.
So you could use the actual. Oh yeah, the mouse. Yeah. So there's also a way to convert back. Let's say you received an object of one of the wrapper classes that you need to convert into a primitive data type. So you can do mathematics or anything with it inside a class. You can go back. So here's an example of some other ways of converting back. You actually do one of the methods of the object, the wrapper class object, int value, short value, long value, depending on the type of variable it is, and that basically assigns that value to that integer, I, or short s, long l, and you can do it with doubles and booleans and characters just the same. Okay, so we say that the methods within the wrapper class are looking for a home because some of them don't necessarily, they don't need to be in that class. They don't specifically do something that is unique to the wrapper class, but they're methods that are used for general computation and logistical sort of things. So they need a class to be home, and since it's easy to declare a wrapper class object, we put them there. Stuff like parsing and things that we use a lot, which I'll get to in a minute. So they're placed in the wrapper class for convenience. And you can convert between different data types with them more easily. And they also store the bit sizes of each data type. It's another method that you can use. So the most common type of method is parsing, which is converting a string value to an integer or a double type, which is not possible for a character or a boolean, but let's say your string value is a number. You need to convert it to an integer or a double to do math with it. This is common when you're receiving input from the like a JOption pane or a text file or some sort of place where you can receive input only in a string format. But you wouldn't be able to do math with a string. You can convert it into an integer or a double depending on what it is. And then reverse parsing is doing the exact opposite thing, converting int or double into a string. And then you convert a string value into an integer object. You can go straight to the wrapper class without coming through a primitive data type, which is much more convenient if you need to do that. So here's 3 examples. The parsing uses the function or the method parseInt with a capital I. Integer.parseInt, actually. And this always creates confusion because it's integer.parseInt, but it's double parse double, not double parse dub or something like that. So I've sat there for a couple of minutes sometimes before trying to figure out why my code doesn't work, because it's not integer parse integer, it's parseInt. But that's pretty straightforward, and then in the argument you put the variable or the number or the string value, whatever it is. And then reverse parsing is integer.toString, which will take an integer value or a double value if you use the double class and send it back to a string. And then string to integer uses value of, which is one of the methods of the integer wrapper class. So there's also base conversion methods. If you want to find the hexadecimal, octal, or binary values of a variable, you can use the wrapper classes. So these are sort of things that don't necessarily need to be in the wrapper class, but if you're looking up specific sort of statistics about a data type, you can't just use int dot whatever, lowercase int that is, or double dot whatever, because primitive data types don't have that sort of information associated with their object. Objects are more complex, so you can find those values with this command as well. And then there are the size constants. They tell you how many bits comprise the data types that the wrapper classes represent. So if you did double.size, float.size, long.size, any of those, these would be the values you'd get. And Boolean doesn't have a size constant. So I have a question for all of you. What do we say, or why do we say that the methods of wrapper classes are looking for a home? It's a new touch, yeah.
Anybody?
Anybody? Oh, sorry, this is the wrong slide. Let me go back. Anybody? Okay. We say that the methods of the wrapper class are looking for a home because they don't need to be there. They're just there for convenience because they don't necessarily apply specifically to the wrapper class that you need to use a wrapper class object for them. They're just general things you might need to do in computation that you can that are put in the wrapper class for you to call upon. One more question. Why do you think someone would want to convert a primitive data type into a wrapper object?
This is actually an extremely important question, guys.
We can use the methods of the wrapper class?
Right, exactly, yeah. So you can find information about the data and do parsing and all sorts of computation and things that you wouldn't be able to do with just a primitive data type. You can convert it. It holds the same value, but it has all these functions associated with it, all these methods, I should say, that give you a lot more usage.
Okay, let's go to the today's meet chat session and see what questions students had while you were presenting, Daniel.
What other methods are available for primitive types if you convert to wrapper equivalent?
Yeah, because you spoke about toString, and you spoke about if, for example, double dot parse double.
Yeah.
What other methods are available?
Well, double and integer are the only ones you can parse. You can't parse a Boolean and a character, simply because you wouldn't need to.
Right.
Parsing is only for the purpose of doing math and computation with a string value.
Right.
That's already in number form. So there's no parsing for characters and Booleans. For two strings, I believe there's integer and double toString, and character and Boolean, or character but not Boolean.
Right.
Because characters can take a string value as well, it's just X or B or whatever it is. But there wouldn't be a Boolean value for that. There may be a Boolean method that converts it into just 1 and 0.
Okay.
But I haven't really looked in depth into that. I can take a look into that because there might be some more. But
Okay.
there's, as far as methods for all the primitive data types, there are short, long, Boolean. All the data types have integer wrapper classes, but the ones we say are the four main ones are double, integer, character, and Boolean because those come up more often than a short or a long.
All right, do me a favor. Go to Google real quickly.
Yep.
And after you've finished, looking up Pesci, go ahead and put methods of Java wrapper class. Okay. Go to, you could go there. Scroll down. Compared to.
Yeah, compared to. There's the value. There's also byte. I forgot byte, and then short in, long, float, double. Decode. There's a lot more. The main ones that we would ever use are parsing and converting between values and then from there we take it outside of the wrapper class. But there are comparison sort of things too that you wouldn't be able to do with an int and a double together since they're odd types.
Right, exactly.
So
because one of the things that you're also going to be doing on the AP exam is you're going to be determining the lexicographic order of objects. So is Daniel with a capital D, where does it go lexicographically compared to Daniel with a lowercase d? Those are some of the things that we need to look at. Okay, and you may want to consider using wrapper classes for things like that. Okay.
So was there one more question?
Can you parse, or can't you parse a character to the ASCII number equivalent?
The ASCII number equivalent. I don't know what an ASCII number equivalent is.
Remember, every
like
character that you input has for example, J has a certain value in the ASCII
Oh, right, right.
table. The umlaut, even the number 7 has a
Right.
ASCII equivalent. The letter lowercase a, for example, has the ASCII equivalent of 32, if I'm not mistaken,
Mhm.
which is different than uppercase A, which has a different value.
I don't know if I'd use the word parse. You can, I'm sure you can find the number equivalent, and then you can.
That will return.
That
right?
will, yeah, exactly. Like you remember the functions I showed you, 2 hex string or 2 octal string, or even
Right.
size constants. You're not technically changing the value of the data. You're not changing the type of the data from integer to double or double to integer back, whatever. But there is a value stored somewhere for that, so you can call upon it. It'll return it, and then you can create a variable with that value if you want, or do something with it. But it's technically not parsing, actually.
Okay, by the way, guys, todaysmeet.com/APCS, I opened up that room for the whole year. So what I'd like to do is I'd like to have you populate it with questions anytime anybody presents, and then we could review some of these questions before the AP exam. Some of those questions may also be included, hint, 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 on our future assessments, okay?
Sounds good.
Okay, any other questions or comments, guys? Okay, Daniel, thank you very much.
Alt P.
Wrapper classes, folks, wrapper classes.